So as I mentioned, what you need in order to just complete this course is Visual Studio. It doesn't matter which version you are going to use, but it is important that it is functional on your device. Therefore, please go ahead, just based on the information that I already show you on Avenue, install Visual Studio 2022 or any latest version, okay? Any latest version. For example, you might find 23, 24, 25. Right now, in the time that I'm recording this course is 25. But even if after that you're seeing any maybe latest version, always try to install the latest version. Visual Studio is a free software. You are not expected to pay for it. Uh, it is available to all students. You guys are required to please use your McMaster ID in order to get access to the actual software for free with no charge. Experience for students who are using Windows is different than those who are using Mac. Those who are using Windows, everything is gonna be the same as what I'm showing on my screen during the class time, because I myself am using Windows. Those who are going to use Mac, they might have a little bit different experience, and the information I already provided for the software may not fully work for them. So you have to please go ahead, Google it, because the Mac experience is just keep updating. I'm not aware of those like updates. It's totally on yourself to figure out adjustment of the Visual Studio on your Mac device. Since I am using Windows, I'm perfect with Windows. I'm confident to share any information about the Windows version of it. Application on the Mac is exactly the same. You are not going to be surprised about the application of how to program, but the display or maybe some of the like features might seems different. So I don't have Mac in here to implement. Please go ahead yourself, spend enough time, figure it out, and just go from there. We are going to start with introduction to computer and programming. That's why today we don't need to really do anything inside the software, but still it is mandatory to make sure that you guys already have the software installed, because tomorrow is going to be your first lab and we are going to have some hands-on experience from first lab. So first lab is going to be same time, same platform tomorrow, and we are going to meet to start programming in there. Let me start with why programming. Before I start, is there anyone who's interested to just share a little bit information with us that why we need programming? Any idea what's the benefit of programming for us in the world of technology? In fact, let me help you with this. In fact, human used to do everything manually. And when we are doing things manually, there are a lot of risks dealing with. Definitely health and safety, definitely even financial risk, definitely even time management and everything. Usually we use computer-based tools and techniques in order to speed up the process and have it more accurate and get it done even more efficient. Troubleshooting with computer-based tools and techniques definitely is much easier than when we are doing everything manually, because we can set some sensors or maybe set some features regarding to that certain perspective or certain project that can give us some warning, some alarm in order to inform us what part of the circuit or device is faulty. So troubleshooting becomes easier, right? And even fixing it becomes easier. So now, in order to start programming, not only we need the machine, which is called the hardware part of it, like a smart system, we need also software. Programming is under the software part of any technology. It's not related to hardware. Also, this software is supposed to be installed on hardware. Like, for example, what we are going to use in this course, which is Visual Studio, is a software, but definitely we need the hardware in order to make it functional. So we need two type of engineers. One software engineer, one hardware engineer. Also, many of us may nowadays be familiar and capable of handling some portion of both hardware and software, which is the requirement for any successful engineers. And I'm pretty sure you are going to be one of those very experts. So now let's focus on the instruction in computer memory. Program is just a step by step, maybe I would say command that we are providing through the software to the hardware in order to get a project done, or in order to finish a process from scratch, or let's say from 0 to 10, right? So that's what we call it, program. Now, who's programmer? You, me, and any other engineer or expert in the field. Users who are going to write down these instructions in order to create an object with some detail are called programmers. So far, so good. Also, these are some theory, basic, maybe all like information, but these are confirming that I'm not even expecting you to have no prior knowledge, even about whose programmer, what software, what hardware. That's why I start from scratch, from zero. Now, I already introduced we need hardware and software, both of them. Both hardware and software are the requirement for computer system. Now, in order to start with hardware components, first thing I want you to become familiar with are those just basic tools that right now you have access. That's why you can see me. For example, you've got your keyboard, you've got your maybe camera if you are on PC, external camera. If you are on your laptop, probably built-in camera, right? Therefore, and you've got some monitor. Therefore, even if you are looking at the hardware, still you have two type of devices being assembled together as a single unit, like a laptop, or maybe multiple unit, like when you are using a PC separately, then a keyboard separately, then maybe your mouse separately, or whatever, monitor separate. But still, all of those are called hardware. Now, some of these devices are input, some other are called output. And I want you to be familiar what part of a computer system is called input, what part is output. Give me some example. Maybe you want to use your microphone. It's good to have some interaction. It makes the class live and active and maybe more attractive. Do you want to name some of the inputs that right now you are using in order to attend this class? Anyone? Kevin, keyboard, microphone. So keyboard and microphone are going your input. 100% correct. Ikra is saying mouse. Yep, correct. So as your friend said, your keyboard, your mouse, your microphone, if you are using an external one, or even if you are using a built-in one, touchpad, Ahmed, you nailed it. I do have that right now in here. This is my notepad. So this notepad, which I'm using my pen also, this is an electronic pen, both of them are considered as input. I write to my screen through my pen and using my notepad. So these are also called input. Now, please come up with some example for the output. What kind of output? Monitor and speakers, 100% correct. Yes. Right now, for example, your laptop monitor. and definitely built-in speakers on your laptop. For me, it's not built-in, for you because I'm using PC, but for you built-in. What else? What other? How about camera, guys? Is your camera input or output? Camera is input. 100. How about printer? Is printer, if you've got one to connect it to your computer system? Exactly. Printer is output. Yes, exactly. Printer is not input. Scanner is input, but printer is output. But if you're using a scanner, also scanner and printer might come as a single unit, but some portion of it is going to be considered as input. The other parts of it is output. Combination of input output if both are coming as a single unit, and so on. Let me show you some of the components as we just practice them together. Like for example, monitor is output, printer is output, speaker in here, all of this that you can see right in here, they are all output. But camera, maybe some of those joystick in order to do some maybe computer game. Also, look at here, a scanner, as I just said, a scanner is input, keyboard input, camera is input. The pad, which like mine is, these are all input devices, and on the other hand, these stuff are all output. Definitely lots of extra units, especially nowadays. Some fancy other unit could be considered also as an either input or output. But something important, we discussed input and output, but still there are something in between, like the memory. Most of the time, memory is built in or RAM is built in, but we have options like previous versions, such as disks, which is secondary storage devices, right? Those are external memory, temporary memory, right? So anything inside is gonna be built-in memory, is included inside your PC. If you are using laptop, inside your laptop, you have no access to reduce or maximize, but still you do have access to use external memory, either your flash, either your maybe like this like discs or CD or whatever. This type, there are like, let me show you disk, floppy. I'm pretty sure none of you has that experience with floppy disk because they don't even exist anymore. Let me see if I can find some image. These are called floppy disk. At least maybe some of you just saw some of this type of memory. These are the first generation of external memory. I myself started with this, like the room in order to store information in this floppy disk used to be just super small, in a way that you couldn't have probably more than one PDF document being stored in one of this. They had room only maybe for one PDF document, not more than that. But anyway, we have started with such sort of disk or floppy disk. And gradually by time, things had some advancement. And nowadays, even we don't use external physical memory. Mostly we use cloud-based storage, maybe for different applications. Do we have access to that as students and faculty right in here? Any idea? Any cloud-based storage? Any idea? Yes, we do. How about your OneDrive? You guys have activated your OneDrive? If not, it's time to do, because we are going to store codes and maybe lab reports and everything for this course, even the projects that we are going to start on Visual Studio somewhere on your OneDrive to ensure that you're not gonna use it. So right after this class, probably you need to go ahead, make sure that you have OneDrive installed on your device and use your Mac ID to get access to your OneDrive, and then you are going to be provided, I don't know how much is the space, maybe 50 gig for you student, maybe a little bit more. You just go ahead, figure it out. For us as faculty, I have 100 gigabyte room in order to store my information. Therefore, you can probably use this type of storage. And the benefit is this type of cloud-based storage is accessible to you everywhere. You do not need to carry here and there any floppy disk, any maybe USB or anything like that, and just deal with the risk of losing it or being stolen or something like that. And of course, you do not need to always have your own private device with yourself. If you are using cloud-based storage such as OneDrive or maybe Google Drive or something like that, all you need is any device. Through any device and your login access, you can log in to your own account and get access to the existing information. Any questions so far? Anything? Okay. So let's continue with the structure of Central Processing Unit, or we call it CPU. CPU is the brain of computer, is where that like uh, codes, program structures of how to consider the comments on a code. And of course, even arithmetic, logic unit, and every other aspect of the computer, either inputs, outputs, software, everything is controlled under the central processing unit or CPU. So when a computer is performing the task that a program is asked to do that certain task, we say that the computer is running or executing the program. Sometimes even we say debugging. First, we have to go through the process of debugging, then running it. In that case, this CPU or central processing unit is the part of a computer that actually runs the program, right? First, it is checking the functionality of the code or the program. It is going to make sure that there is no error. Everything is used as it's supposed to, and then it will run it. So CPU is the most important component in the computer. Why? Because without the CPU or processing unit, computer couldn't run any software, right? And usually, definitely for running a software, we have to have access to inputs and outputs. So CPU by itself has two parts. Control unit, as you can see in here, is one part, and arithmetic and logic unit is the other part. Control unit, as you may see it right in here, is actually helping with the computer's operation. That's what we call it, control unit. It's responsible for understanding where to get the next instruction and regulate the other major components of the computer with control signal, right? So how about arithmetic and logic unit? This one is, like the name is suggesting, the name is arithmetic or logic unit, is designed to perform mathematical operations based on any object or project that you are working on it. So it's kind of the brain. CPU is the brain of your computer. This is the structure. So we've got some input. We already discussed which kind of devices could be the input. We've got some output, but in order to pass the input to output, we definitely need to have some CPU, some central processing unit, because we need some mathematical operation using some logic. And of course, we need a control unit. As I said, control unit is helping with the computer operation. So this is the structure of the CPU organization. Now let's look at main memory. Any idea what is the main memory, since I already introduced some of the storages that we may use in order to store data? Probably some of you have heard about it. If so, please go ahead, feel free and share some of the information that you have. Nothing? Okay, main memory is somehow the computer's work area. Simply is known as random access memory. You can see I already mentioned it in here. We call it random access memory or RAM, right? So it is called like the RAM simply because CPU is able to quickly get access to the data and use them in order to, for example, store them at some random location. Since computer is getting access to those data and it is going to store them in random location, not some a specific location with some certain address, we call it RAM. RAM is usually a type of memory that is used only for temporary storage while a program is running, right? Simply means if the computer is turned off, connection or any connection to RAM is done. You have no more connection to the RAM, right? So RAM is accessible only up to the point that your computer is on. And of course, content of RAM are going to be erased as soon as you turn off your computer. So inside your computer, RAM is just a small chip. There is a physical device for RAM. It's not software. It's a physical device called, it's a chip, which is called RAM. Computer memory is divided in two types of storage, as you can see right in here. So those locations are known as bits, which is the smallest part, and byte, which is the a bit larger part. Still, we have larger size as well, but here in this course, we deal only with bits, which is the smallest piece of memory, which is just holding 0 and 1 as true and false. As I mentioned right in here, true and false, 0 and 1, off and on, all of them are addressing the same thing. Don't get confused. Excuse me. And byte is at least 8 bits. So combination of 8 bits is gonna create 1 byte for you, right? So that's what we call it, byte. So in order to make sure that we can do some stuff, maybe programming or just dealing with both software and hardware with our computer, definitely we have to have a lot of bytes. Most computers today have millions of bytes, or even billions of bytes of memory, especially those fast computers. Definitely, in order to process information, they do need even billions of bytes of memory. Each byte is divided, as I said, into 8 smaller storage location, which is called bits. And the very last part about the memory that I need everybody to remember it, because we are going to use like, for example, addressing during the programming as well, is the address. So what is address? Each byte in memory, each of this byte, remember I said each byte is 8 bits. Now each of those 8 bits, which is 1 byte, in memory is identified by a unique number called address. So for each 1 byte, we do have 1 address. Or for each 8 bits, we do have 1 address. Let me write. So suppose that this is a byte. So each of this is a bit. 1, 2, 3, 4, 5, 6, 7, and 8. Starting from 1, right? And ending at 8 bits. Suppose that we have 8 bits equal to 1 byte. Now, each of this 1 byte has one address. Make sense? If not, please feel free to ask question. Yes or not? So, talking about this, let's look at the main memory location. Remember, I said each of this might be 1 byte, and each of this byte, they do have one address. So starting from 0, for example, to 29, these are the number of the byte. And what you see in here is like, for example, 149 stored in 1 byte, right? So this is a byte, this is byte 23, and I do have one number in here or another number in there. It is stored, for example, 149 is stored in byte 16, 72 is stored in byte 23, and that's the way that CPU is organizing the information. Another type of the storage we already talked about is such as CD-ROM, DVD, USB, or nowadays cloud. Cloud is also still considered as secondary storage because it is not built-in storage. We consider it as secondary storage. We did not have the cloud storage before. It's like a couple of years we do have like cloud, which is a free access storage. We can get access to it everywhere. It's still considered under the secondary type of storage. Secondary type usually is either a hardware, a physical tool, and it may come with different sizes based on your application. You can pick the right one for your application. And these are going to be connected to the computer if it is a physical device, such as floppy disk that nowadays nobody is using it, or such as hard drive that even rarely, I myself have a couple of hard drive, but I use them rarely. CD-ROM, DVD, they are old version, and most of the time nowadays nobody is using them, but still they are considered, and we have to name them and introduce them to students. But flash drives or maybe USB, we call them most of the time USB, they are still available. We might still use them, but the most maybe available one nowadays for everybody, and I'm pretty sure you're gonna start using it from this semester yourself, is cloud. So that's why I said make sure that you are going to activate your OneDrive and just go from there. Input devices, we already discussed them. Software program are those programs that most of the time they do use some compiler, and compiler in simpler word means a translator. For example, since human language and computer language is different, definitely in order to translate human language to computer language, we need a compiler. So compiler is a part of software requirement for any computer. Therefore, that's, for example, one software like for example your Word, which I would say Office, your PowerPoint, Excel, these are all still considered software, although you are not going to just do any programming through, for example, Word document or Excel or PowerPoint, but still they are considered some sort of software that you need to install them on your hardware. Next is about the languages. As I just said, for different software, we may use different languages. Or, for example, today we are going to learn how to use C++ in order to just program creating an object from scratch. But next semester, still it is C++, but advanced version of it is going to be object-oriented. If you are going to meet me in the first year, if you are automotive students, then in there I'm going to introduce even C, or maybe in other courses you may be introduced to Python, or even some of you may have that information right now, and many other programming languages. So those languages, each of them, they do require maybe some different compiler in order to translate human language to computer language. Computer language is based on 0 and 1, right? So definitely It's not, for example, whatever I say verbally in here, if I ask my computer to do it, it might not make sense to computer. So let me just give you one example of algorithms for calculating maybe gross pay for a grocery store, or maybe gross pay for any maybe any employer anywhere. So in order to do so, first we have to figure out how many hours did you work. So can I ask my computer in here, can I ask my Visual Studio exactly the same way? Say, hey, figure out how many hours I worked this week or this month. No, definitely I have to convert this to some logic, or I have, based on the software that I'm using, or I have to convert this to some maybe arithmetic in case I'm calculating something, or so on. Now I'm asking wait for user to enter the number of hours. Therefore, I have to create some interaction between computer and human. Computer by itself cannot work. So I have to ask the question and I have to give it some weight for me to send new information as an input. Then I have to display the message. Therefore, I need some output. So it's a combination of input, human interaction, and output. Here is the input, here is the human interaction, and here is the output. But in order to receive information on my monitor, I need a compiler first to translate this one to machine language, maybe do some calculation also, and of course then display it on the monitor. So then I have to say wait for the user. If I ask how much do you get paid per hour, first how long you work, now how much per hour. Again, I have to ask for another user interaction. And finally, I'm gonna expect some message on the monitor in order to just display all of the requirement from a step 5. So this is a step by step creating a code in order to, for example, calculate how long I worked this week and each of the hours that I work worth how much. And finally, based on that, maybe calculate my income for a week or a bi-weekly, or I don't know, monthly or so. Therefore, it's not just maybe one command. Definitely you have to go through a process in order to ask the computer to do the calculation. Machine language, as I said, is just some algorithm. In order to get access to that output, definitely you need some processor. And machine language is different than human language. Therefore, look at here. Machine language is binary. Earlier I said is a combination of 0 and 1. Machine language is not, like, for example, starting from 0, 1, 2, 3, 4, 5, 6, and so. It's a combination of zeros and 1 rather than human language. In human language, it's a different story. Any questions so far? I'm gonna give you maybe a few minutes of break. It's just almost an hour from the class. I'm gonna pause for 5 to 6 minutes. In case you guys have any question, feel free to ask. I'm gonna just write in here, stop sharing, pause recording, and I'll be back. I'm at least writing here. You guys can go for some break. I'm still here to collect your question if you have any, and then we will resume. Uh, Okay, let's continue. We already discussed some type of languages. I already even named some of them. For example, as you can see right in here, C++, Java, Basic, Fortran, many more, Visual Basic, Python, and many other languages which might not be in this slide in here are available nowadays in order to communicate with computer and create an object accordingly. But among all of those, we have two type of languages, generally regardless of which uh, software or language you are using, we have two type of languages. We call them low-level language and high-level language. Usually low-level language are those which we are using in order to communicate with some hardware directly. right? And sometimes even we call them embedded system. Usually most of them are using binary machine code. I just said binary is a combination of 0 and 1, something like that. Low level means a combination of zeros and 1, right? But high level languages are really closer to human language. Therefore, those are somehow easy to understand and readable for human. Those are not that much complicated for humans. So we call them high level languages. Computer CPU can only process instruction that are in machine language, either low level or high level, but still both of them are readable and understandable for the computer. So now you know that high level language is easier to understand for human because it is more close to the way that we talk and we communicate, so more details. But low level language are just a combination of zeros and ones, and we don't really understand that. Computer can understand it. So is it more close to the computer, which means it's look like the numeric machine language. It's not like alphabet. It's just numeric machine language of the computer. It's more than the natural language of human. So we just looking at all of the zeros and one, we may not really understand it, right? So that's why we call it low level. And these are some examples. And now, as I just said, high level means human language, but computer directly cannot understand human language. We must convert human language to machine language. Therefore, we have to go through some process in order to convert human language to machine language. What are those processes? So, for example, we have to create a file contain the program with a text editor. Then we have to go ahead debug it, right? Or after it is like we create a source file for programming here in C++, then we have to debug it or compile it. Compile it means whatever command we are using as a program being injected to like Visual Studio supposed to be compared with some compiler information inside the computer. If it's aligned, it's like a library. Compiler is like a library of information. It's just pre-made, ready, existing information inside the computer. So if whatever we type as code or program into the software, is aligned with whatever existing inside the computer, then if it match, there is no error and we can compile it, or let's say we can run it. After the compiler run it, we can convert it to some output, and that output is still understandable for human. So we have to go through this process. Some of them we are involved, we have interaction, some of them is happening inside the computer, and at the end, if things are correct, no error, then we can see the output. So let's look at this maybe high-level program to an executable file. Executable file simply means output, right? So first we have to provide the code, like for example this code. Later, especially from tomorrow, I'm gonna start helping you how to create the template in order to program. So for example, just for now, have it in your mind. In order to start programming, remember I just used the term library, right? We can call it library or header file. For every single project that we are going to create based on which kind of logic we have to get access to that certain library or header file. For example, IO stream in here being enclosed inside this bracket is called a header file. Don't worry at all. Over the classes, upcoming classes, I keep repeating and repeating this information. Therefore, don't feel overwhelmed because these are new for you and I truly understand it. This information, these names, this maybe definition, I keep repeating them over the semester, over and over and over together until they become familiar for your brain to understand them. So we start with hash include, and then we include, in this example, iOS stream. In other example, maybe even more additional header files. And that header file is a source of information that we are going to, underneath this hash include, provide some information. All of those most match to the information inside this header file. Otherwise, we will get error. Otherwise, they are not known for the computer. They are some characters and maybe syntaxes or this and that, which are not known for the computer if we do not address the right header file. So having a header file is mandatory. So that's what we call it, the source code. We provide the source code that will be injected or moved to the processor of the computer. After that, it will be modified, and the compiler could be a built-in compiler, means like it is provided with the software. We have no, for example, for Visual Studio that we are using, it has a built-in compiler. If there is no built-in compiler for some software, we have to go pay for extra compiler externally and bring it and install the compiler manually ourselves. But the package of Visual Studio that we are providing is already have like that necessary compiler. You don't need any extra installment. Just go through the process of installing like the Visual Studio, and the compiler is included. Then compiler will look at the object code, which is just the same code in here, and through the process it will compare it with the information of this header file. If everything feels right, then it will like generate the output, which in here we say, okay, there is no error. This is an executable code, means it is functioning properly. So this is a flow chart which is introducing how a program being provided through a user like yourself to the computer is going to be processed until you are going to have an output. Next, let's look at some of the, I already explained in here, some of the requirements in order to make you familiar with the software. I'm done with the introduction about the hardware. I introduced like input, output, even compiler, even some of the like memory, external memory, or let's say secondary memory or internal memory. I'm gonna pause for a few minutes in case anyone has any question regarding whatever I have discussed so far from the beginning of the class. Feel free to ask, and then I'll continue with the rest, which is going to be more focused on Visual Studio. Meanwhile, that I'm waiting for you to ask question, I'm gonna create just a blank project. Later, I'll teach you how to do this step by step. Now, I'm gonna just give you some maybe understanding and introduce the platform at this point only, nothing more. So question? Anything? Everyone okay? At this point, I'm going to focus on how this Visual Studio should look like if this is going to be your first experience with Visual Studio. Either you can create an empty project anytime that you are going to use Visual Studio, or you can use console app. I show you both. Empty project is gonna provide something like this. Look at here. So you are going to have a blank windows, and you have to do a little bit more effort in order to define your project and everything. But another option to make it easier for you, and both of them are practical, both of them are correct, is just instead of empty project, choose console app. If you don't see them on the side the way I do have right now, it's okay, because this is going to be your first time using Visual Studio. That's why you cannot see them. How many of you, if you don't mind, raise your hand? I can just check. How many of you already installed Visual Studio on your devices? Please raise your hand. I can see it right in here. Ahmed has it. Just Ahmed? How about everybody else? Hamza? Anyone who has the Visual Studio, just raise hand because I'm going to count on the numbers and see where we are and go from there. Good job. Everybody else, if you do have the software, feel free to, a good number of students in the class, they do have it. More? Others? Do you have it? Okay, good number, but not everybody. At least they don't show their hand up. If you are hearing me, if you are really in the class, not here and there, please raise your hand because I want you, if everybody is having it, then I can get you to follow me and create your first practice. That gives you a great hands-on experience. So more? Anyone else? If you do have Visual Studio on your computer being installed properly, raise your hand and that gives me the option to start training you with how to create your blank project or how to create your template. Good. So at least more than half of the class numbers are raising. They do have the software. That's a good number that I can see on my screen. Therefore, please feel free to click on your Visual Studio, activate it, and come to this step. If you don't know how I got into this, I'm gonna close everything and I'm gonna start from scratch and I'll get you. Please practice with me. Okay? If you do have two screens, perfect. You can just move me to one screen and open your Visual Studio on the other one. If you are using only one single screen, minimize me and listen to my voice. I try to explain it in a way that even if you are only listening and you don't see what I do, still be able to follow me and create your project, okay? So minimize me if you are using one screen. Go to your main page, find the Visual Studio, regardless of what version you have, click on it to become available, okay? I'm gonna even close this one, but it may, if I close it, it may take time. After you have it, then click on create, then you are gonna see exactly what I show you right now in here, right? So after you click on your Visual Studio software, then you are gonna see create a new project. Everybody follow me? In this step, you have option to use either empty project or console app. My recommendation, since you are beginner, start with console app. Console app by itself, if you search, you may have other options too, but make sure that you do choose the one that comes with C++. Another thing that I'm going to remind everybody, some students, they do confuse Visual Studio with Visual Code. Kids, these two softwares are two different software. I'm going to even bring them up right in here. Visual Studio is a different software than Visual Studio Code. Look at here, I do have both on my computer. I'm showing it to you to make sure nobody is going to get confused. So Visual Studio is the one that we use for both one CP3 and one PR3. We have nothing to do in either of these courses with Visual Studio Code. Maybe other courses, but not these two courses. Both of them, make sure you are using Visual Studio any version after 2022. Any version, okay? So hopefully everybody's on the same page with me. If so, I'm going to be confident to click on console app and I'm going to check this is C++. Double click on it to move to the next page, which is configure your new project. Everyone following? Yes or no? Let me see if I can bring everybody's hand down to make sure if anyone has question. Perfect, Ryan. Perfect. So if you don't mind, bring your hand one time down, everybody. That will help me in case some of you, your hand is up for question, then I can collect that question. But if, good job, everyone is going to become expert with raising and maybe dropping the hands. So anyone now, feel free, anyone has question, either use your microphone or raise your hand. I'll try to keep checking the attendees and then participant to make sure you are going to get the answer to your question on time. So at this step, I'm going to practice creating my new project. First thing first, kids, this is mandatory to make sure that you are going to define a project name. By default, Visual Studio is always considering a name for your project. At this point, I'm just doing something as an example. It doesn't matter really what the name is. But for example, if you are going to practice your lab 1, you may want, in order to be approachable and later be able to find the program or the code for your lab 1 being stored on your OneDrive, maybe you want to store it as your project name is lab 1 or maybe assignment or anything accordingly. In here, I'm going to give it example. This is going to be just for practice. The very next important option, remember I said maybe here is the time that you are going to use your secondary storage. Maybe you are going to either use your cloud, or if you have enough room in your computer, maybe you want to directly store your code on your device. I don't recommend it because after some time, especially with laptop, which is most of the time limited with storage, if you keep storing all of the code directly on your laptop, after some time your laptop doesn't have enough room for process. Okay, therefore I recommend in here, just right now with me, if you have no idea how to set up your OneDrive, it's the time. Follow me, set it up, stay safe for the rest of the semester. Just go under the location, click on the 3 dots in here. Make sure that you have the OneDrive being installed on your device. If you don't, then you need to go back later on your own time. I don't want you to focus on it right now if you don't have OneDrive. But if you do, follow me. If not, after the class time, click on your Microsoft 365, which you do get access to your email, your office, and everything through Office through 365. In there, you can download OneDrive, install it on your device. Even if you go to Google and Google OneDrive, for example, it will give you the option to download it even from Google, but still you need your McMaster access to activate your OneDrive. If it is already activated, maybe during the other semesters, choose your OneDrive the way that I do. And then, for example, go ahead, define maybe some, for example, I put this one under 1CP3. Maybe this is summer, but whatever. I'm going to put it in here. I'm going to create a folder. You can do exactly what I do. Create a brand new folder. I'm going to call it summer, maybe 2025. And I'm going to store all of the assignment, lab, practice, whatever I do for you over the time of the course, I'm going to store them under this folder. So I'm going to select it. Now, maybe your question is, do I have to do this every time? No. If you set this up one time properly, now on every other brand new project that you are going to create is going to be automatically stored under the same folder. But still, for the first couple of times that you are using it, since you are not sure you did it properly or not, keep checking. If it is not there, select it, right? And then the rest, for example, here, create new solution and example and stuff, you do nothing, leave it. Just give it a name and set your location properly. And just on the corner, if you see my screen, on the bottom right corner of your screen, you do have an option called create. Hit the create. Guys, do you mind kindly raise your hand if you are following and learning? I don't want anyone to stay behind. Yeah, good. If you learn this properly now, you are going to have a good, maybe easy time next time. Perfect. So at this point, can you explain about the location section again? Sure. Location section, in that case, I have to create a new project because it's not accessible. I already processed it. I'm going to do that one more time. Suppose that you are doing one new project, any other new project. You choose your console app, you hit next. Under the location, by default, your computer is assigning a location for you. Either you can consider that if you have no concern about running out of memory in your personal device. But if, like myself, you do have that concern that if I keep using my personal device to store different information, at some point I may run out of enough storage and bring down the speed of my computer. Therefore, you can go ahead, hit these three dots, and if you have OneDrive already installed on your device, choose OneDrive. Then automatically everything will be stored right on there. And it's not gonna occupy any storage or memory from your personal device because all the files are going to be moved directly to OneDrive. And that helps you to still keep your computer fast enough, not to slow down. Hopefully that helped you. Yes or not? So since I already created one, I'm going to close this and I'm going to go back to the one. Perfect. Perfect. Good. Now, after you created your new project, congratulations. You are in. Welcome to your first experience using Visual Studio. Well, all of this information that you can see in green is just an example. Do you need them? Not really. You can simply remove them. Any information that you can see is starting with slash slash. In programming, we call it a comment, not command. Comment. Comment means something that it is not active in the process of debugging. Anytime we don't want any of these lines not to be considered for the debugger, we simply add two slash at the beginning. Not only in C++, you can do the same even in C. Yes, Karen, do you have a question? Feel free to ask. I see Potter and Karen's hands are up. If you guys have question, you're welcome to ask. No, that was not question. Okay. So now you know that. What does it mean if I have a slash and my line turns to green? Anytime you add a slash to the beginning of each line and it becomes a green line, simply means you are deactivating, or the right word is commenting that line. That's what we do in order to sometimes simplify. Now, in here, you can see also these are comments, but these comments are provided for some beginners like yourself. Therefore, feel free, give it a minute to review. In here, I'm asking, okay, if you wanted to debug, you've got a couple of options. Either you can say Control plus F5, or you can simply look at the top of the screen. I'm going to introduce only, today I'm not going to teach you programming. I'm going to introduce the software. So no stress, just follow me and make yourself familiar with the structure of software and what does it mean, this one, that one, and how to find this or that. So here, this green triangle, this will give you the option to debug your code. That's one option. The other option is the one out, right? So either you can push local Windows debugger or you can push start without debugging, either of these two, or simply even don't press any of them. On your keypad, press Control plus F5 to start without debugging menu. Now, if you want just to debug the program, you don't need Control, just press F5 or simply press this one, which is the local Windows debugger. In order to start, as I mentioned, use the Solution Explorer windows. Remember at the beginning when I created the new project, that was there. We don't do manually anything, we just need to know that's in there. Most of them are already automatically provided to you. So you may want to just review them and just get rid of them. We don't need them. That's some basic instruction. It's not a part of a code. So far I learned, I'm going to review for everybody. This is the windows that I need. I'm going to move my picture, bringing it to here to show you the side. So in this windows, you can see in order to create a new project, maybe even something in addition to the existing one, you have the file option, you have to hit, you have to select new, create a new project. That's how we create a blank new project in addition to the one that we have. In order to add new project, we have another. If I hit add, it will be added same way as the new project is working. So I don't need it, so I close it. In order to edit, we don't usually edit, but still the edit option for some reason is just frozen. Now it is back. In order to edit, for example, to cut, to copy, to paste, just hit the edit option like many other softwares. View is giving you option to look at the solution explorer. This is a good thing that I wanted to touch it right in here. Many times during the class time, I see kids just randomly, they close this solution explorer. It's normal. We are human. We may do mistake, right? So maybe just randomly, in case you close this, if you hit this X option on the side of your Solution Explorer, first remember the name. The name is Solution Explorer. If you randomly close it, how do you bring it back? You have to go back, click on View, and select Solution Explorer. That's one option. Second option is you can use Control Alt L on your keyboard and it will bring it back for you. Now, I'm going to give you some tips. It's not only the Solution Explorer. Students might accidentally close it, and since you are beginner, then you don't see it, you freak out, you think something is wrong. First thing first, don't worry. Come back to the view anytime any of these windows became unavailable to you. You can bring them back right in here. The one that I said, Solution Explorer, usually we don't look at Git change a lot, but in case you need it, it's here. Maybe Test Explorer or any other toolbars, task, output, any of this you need in order to be displayed on your windows. In case you just close them accidentally, you can bring them back under the view. Hopefully everybody got this point. This one is not really something. Project, again, you can add maybe some new items, but the difference between this project and here, file, create new project, this one is creating a brand new project, but the one in here, you can add existing text file or maybe other information to the existing project. It's not creating a brand new project, it's adding new items to what we have. And over the semester, I'm gonna practice like how to add new items also. For example, if you wanted to add a new item, which is a text file, if I do have like this text file, if I select it, it can become accessible under your Solution Explorer right in here. That's why sometimes if Solution Explorer is not available, some student may think something is wrong. No, it's not wrong. You can bring it back. So any new item can be accessible through the same windows instead of you giving access to another new project. And also you can see it right in here as well. And you can just move between these tabs. This is the source, for example. If it was a text file with some information, all of the information would display right in here. But this one was on empty as an example. Next is going to be built. Built is the option that we usually, after we are done with the process of coding, sometime before we compile, simply because sometimes we are not done with the code. We just want to make sure there is no error. Also, we are planning to continue and add more lines and add more commands, but still we wanted to try to make sure everything is so far working. In that situation, first we are going to build the solution. Just hit build the solution. Any error will be available to you right in here. Look at here. For example, in this case, I have no error. That's why I've got the green check. in here, no issue found, and I see there is no error being listed down right in here. So that's the functionality of that build solution. Now, if I am not even done with the code, and still I'm gonna check, like for example, I'm planning to provide or maybe prepare a very huge file as a program, therefore I have to hit that one at some point to make sure so far I have no issue and have like maybe a hard time to troubleshoot later, then I can continue. That's the benefit, that's the advantage. Make sense so far, kids? Any question so far? Are you following? I try to dress. Yeah, perfect. I know it is new 1 month. I keep repeating, kids. I know this is new. Yes, yes, you have to go to console app. I know this is new. Once again, I keep repeating it because I truly want that confidence for every single one of you that you guys are being trained right now with me, with my understanding of you. You have just no experience. I know, even if you do have experience, still I consider I'm dealing with those who are blank, and I must, and this is my responsibility, to give them all the detail and basic information. So at any point, anything is too much for you to digest and handle, stop me and ask me to repeat. Okay? Ask me to repeat to make sure everybody got the point. You are expected to learn right in here. And I'm here from heart to share what I know with you. Okay? I want you to have that confidence. So I think we are good in here. Debug, I already explained. We've got a couple of options. Usually we use either start debugging under the debug. You can use either of these two options, or you can use your keypad. And in order to use your keypad, those like key functions are provided, like F5, Control F5, or so on. We don't use the rest that much. Therefore, we don't want to focus on that one at this point. Whatever I have in here, I already said. If you want to comment something, add a slash as soon as your line turns to green, simply means that's not active anymore. But anything inside the code must be included at this point for one CP3. As like basic programming, we must always include include IO stream. Remember when I was just on the slide, I said IO stream is going to be considered as a header file. So these are keywords. We are not allowed to adjust them based on our own preference. We are not allowed to make them lowercase or uppercase in different cases. If it is like, for example, lowercase, it's always lowercase because the compiler has the lowercase version of it. If you, for example, this is int standing for integer. If I adjust this to int, look at here, it's gonna give me error, and I can see in here that 2 error. So int, so it simply means it's sensitive to uppercase and lowercase. It must be always lowercase. As soon as you see this is color, for some of them turns to blue, some of them turns to uh, like brown, or maybe other colors for other commands, but still it must be as I train you during the semester. Another thing is about your windows or maybe your screen. You can change the color, right? You can leave it as white the way that I have it, or you can just go ahead and maybe use other, maybe customize a screen and this and that and change the color. If you would like to, you can customize your font, you can customize your comments, your text editor. You can customize either of these. So since those are not mandatory, those are options for some students. If you are interested, go ahead, look at under tools, look at what do you have in here. You can, as I said, change the theme. Right now I do have it as blue. You may want to make it like blue extra contrast, then the color is gonna change, as you just noticed, or you may want to change it to any other color. So these are just fancy options, not technical options. So I leave all of those fancy options. Some students, they do want it to be dark, then you can just make the whole screen to become black. But since I am teaching, it's not something really good for me to teach on a black screen to a student. So I go back and I just leave it as it was. But you guys have option to adjust it based on your own preference. Those are some fancy options right in there. Extensions are not something, again, mandatory. There are some customized menu in here. You may want to explore them. But generally, for example, if you want to add some extension menu, you have to just, I don't have anything like, for example, available. Those are extra stuff that you may want to buy them or maybe install them or so. For your font and stuff, you can also just look at the customize. I do have those options under the tool for everybody. You can see the command line. You can have the option to just customize environment, customize all of this text, test, all of this is the text. You can customize your text, make it bigger, smaller, change the color, change the font, and all of those fancy stuff. Like, for example, some of the stuff that you do have for the Word document and so. This is all I have to share about whatever you have in here. Like, for example, first line. Second line in here, you've got the like new project. To if another option to create a new project, directly you can hit this one. It's gonna give you the option to create a new project. Or you may want to just get access to a file and through Visual Studio open a file. In that case, you may want to just go ahead and just click on this file and get access to your personal device or OneDrive or so on and open another file. Another option is save example.cpp. If you hit this one, it's not going to save everything for you. My file in here is called example. It's going to just save only this .cpp, right? .cpp is what it is used as a file type, right? So this is the name for this file type. This file type in here is .cpp. So it's going to store or save only the .cpp file. Or this one is save all. If you want the save all, everything will be stored about this file. The rest is just debugging, I already said. And I'm going to move to the Solution Explorer. In fact, we are not going to use the Solution Explorer that much for one CP3. But I'm introducing all the details because we need them for one PR3. So therefore, look at here. At this point for this course, this is basic, one CP3. We only focus on .cpp, okay? But later in the next course, which is object-oriented, I'm going to teach you to create even header file or .h file. In that case, of course, you have to have proper access to Solution Explorer to move between your .cpp file and header file. Any questions so far? I'm going to stop right in here because we are done with the second half of the class. I'm gonna just give you a few minutes. Please feel free to ask any of your questions. So all of the explanation that I provided so far is gonna just speed up your learning because I already, instead of just going through all of this information through the slide, I gave all of them through the actual software. Still, in order to make sure you guys have some source or maybe some reference, not only my recorded video, which will be provided later, still you can come back to here. I'm going to quickly review anything that I said. It was all of this information. It was just about the environment for. No, today we do not have a class quiz because still you haven't finished any lecture. But from next Wednesday, or let's say from next lecture, in every lecture we are going to have a quiz about the previous lecture. So this is another thing that I want to remind everyone. So now next, after the break, I'm going to come back and now I'm going to introduce some of the keywords. I try my best to not to stick only to the slide and get you to see it, practically inside the Visual Studio. I'll push the slide to the one side of the screen and the Visual Studio to the other side, and I try to introduce the keywords, programmer, defined identifiers, operators, punctuation, and syntaxes to you. I'll give you some example to make sure you guys are familiar enough with all of those. And then of course, I'm gonna try to maybe run a very small code for you just as an example to show you after going through all of maybe the same code that I have, I'm gonna define it as like maybe an example, which I already did, debug it and show you the expectation on console to give you some understanding and make you happy that you already learned something in even the first session. So go for a few minutes of break. Please come back after of maybe 5 minutes from now, and we are going to continue with the rest. Enjoy your break. So we'll come back to the last part of the class. At this point, I'm gonna just give you a little bit more detail about maybe some of essential requirement. Still, also it might be considered as basic, but we always consider the basic, learn the basic to gradually become experts and maybe use all of the advanced features. So some of the basics, maybe one thing for those who are not familiar with how to split their windows, you can simply just hold the start button on your keypad and then hit the enter. That naturally will split your windows to two sections, okay? And it's giving you option to at the same time have maybe two documents being displayed, which I'm going to do that to make sure that you can see at the same time the lecture slide, and I'm gonna go through them, implement them on the software to make sure that you have enough information about the requirements. So keywords are any word, but a specific word, not human language, not human word, that we are using to command the software to implement some maybe task or project for us. Like what? Like for example, ints in here. Also later I'm gonna introduce ints is a data type, and data type is a keyword, but still int standing for integer. Integer is a type of data, which we call it data type. Data type might be different type. Like for example, in case we are going to use alphabet, we have to use another data type, which is a keyword, such as what? Any idea? If you are going to use alphabet, which kind of data type? Let me see if in this example I have some. For example, like a string, std. No, std is not about alphabet. A string is a data type. A string I don't have in here, but like I'm gonna type. Since this is just a command, I'm gonna type, for example, a string. In case I'm gonna use maybe something like A, B, C, or so on, I use the data type. So a string is a data type, is one type of data type. Another example could be like integer. Int standing for int standing for integer. So when I use integer, like for example, anytime that I need some number like 1, maybe 2, 3, or so on, in order to use any of this number or do some numerical process, I can simply use int, and I always must use it with lowercase. I can never use capital, okay? So I use int. Now main is a variable, right? In general, main is still is a keyword, as I was talking about keyword in here. Still main is a keyword, means it has some definition inside the header file, but this is a keyword as well. So it's a variable. In case you are going to create your own function, which I will teach you later to create your own customized function, you can pick any other name instead of main, but you may always want to remember this. Regardless of this whole thing is called a function, okay? This whole highlighted in blue is called a function in programming. But you do have option to create more customized function underneath or above. Both of them are technically correct, but I always ask a student to please make sure that you are doing underneath the main and always keep main on top, because you have to call every other inside the main, so you don't need to scroll down forever. Then if you keep main at the beginning of your code, it's much easier for you to call other functions inside the main. That's why. So main, you cannot customize it. That's why it's in brown. So you must keep it as it is. That's why we call it, those things are also a keyword. Std, cout. Cout is another command that we use it in order to print out something on the console. I'm going to show you the functionality of this code shortly. So these are what we call them keywords. So now you have a good understanding. Keywords means any word that is associated to the library of this certain software in here, and we have no option to customize it. For example, remember I said this is int standing for integer, but not only I cannot change it to uppercase, also I cannot add more letter, like also integer has more letters at the end, but I cannot make it even int e. If I do so, then the color will change. And since int e or int like, or integer, or if I make it integer, it's not a known keyword anymore for the compiler. That's why it becomes underlined red immediately and is considered as an error. If I hold my mouse right in here, it's showing as an error. So that's why I must keep all of the keywords as it is. Next is programmer defined identifier. Identifiers are, I already at the beginning, I show you don't play with the identifiers too much because those are just something that it is included. Operators are something I'm going to show you both of them. These are the keyword I show you on the Visual Studio, and I'm going to show you on the slide some example, like for example, main, double, cout, but hello world is a keyword or it's not? Somebody answer this question. Hello world in here is not a keyword. Yes, exactly, Kevin. It's not a keyword because this is my customized command, right? So I can include any other sentences right inside this bracket. So this is not a keyword, but backslash n is a keyword. I cannot, backslash n in here is going to help me to move to the next line. So some of the keyword you can see using namespace, int, double, return. These are keywords I just said. Identifiers are something, as I said, inside the C++ language. We don't really have access to them. They are in the variables in the memory location, something like that. For example, in this program, 1 that I have right in here, something like hours, rate, pay, they can be also, they are my own customized variables, but they do have identifiers inside the memory. Like for example, for hours, I can consider like age. For rate, I know this is numerical. For pay, I know this is, so these are what we call them identifier. So they have some special the identifier, not the keyword. They do have some special space in the memory location. Next is operator. Do I have any operator in here? Yes, I do. For example, colon, colon in here, right? This is what we call it operator. Or if I am going to maybe calculate something, like for example, if I use plus or addition, minus or subtraction, asterisk or multiply something, or I'm going to divide something, all of them are arithmetic. Anything or even equal sign. So they are all what we call them operator. For example, if I define in here, like for example, maybe int, and then integer is just a data type, then I have to give it a variable. Maybe day is going to be my variable. And then in here, I can, for example, say day equals, maybe I'm going to use maybe numbers, 2 plus 1, and then I'm going to close it with some semicolon. So I simply created a line. In this line, I'm going to say my day is going to be the maybe work day, my work day. And here I have to have it exactly the same. My work day is 2 plus 1. So I'm using plus. Therefore, this is going to be called or considered as an operator. Okay, so this is what we call it, operator. I'm using equal. This is what we call it. Assignments in here, if it is 1. But later I'll teach you if I have two, if I have two of them, like for example, equal, equal, then it's going to be considered really equal like the way that we use them in math. But if I have only one equal, it's not acting as arithmetic. That's why it's not included in here. It's not included in here. It's acting as assignment, means assign my workday to 2 plus 1. Now, other operator, like for example, I can have shift to right, shift to left. I have assignment. I have like asterisks. They are also in program 1.1, which is this one. I do have some of these examples. I'm going to go back. Like for example, as you can see, I have pay being assigned to hours time rate. Or I have C in rate. Means this shift means Cin means input, in stand for input. Cin means input. C out means out stand for output. Means in here, first output, how many hours did you work? And then Cin the hours means now use your keypad or keyword and input the numbers, maybe like 2 or whatever, and then again output that one. So cin is a command giving you access to interact with your uh, software, and cout, as you can see in here, is giving you access to just implement or print out the information on your console. So any question, stop me and ask. I don't want to explain too much, make you overwhelmed, and then not to be easy to follow. Everyone okay? Can I continue? Good. The last one is in here, punctuation. Any character mark to end the statement, like for example, the semicolon. This is what we call it, punctuation, right? Or if I use, for example, comma, if I am having multiple statement, I'm going to put it under a comment. If I use comma, or if I use maybe colon or semicolon or whatever, these are what we call them. We call them punctuation in programming. So let me show you a few examples. This is one comma. These are punctuation. This is what we call it, semicolon. Remember, in any program that you are going to provide, including a semicolon at the end of the line is mandatory. If for any reason you don't close your line with this semicolon, simply you are going to get error. You must close not all of the line. For example, a start of the function, you don't need semicolon, but anything inside these two parentheses must be closed with semicolon. Otherwise, you are gonna get error. So these are all called punctuation. And next one is syntax. Syntax generally is not something like, for example, arithmetic or like punctuation that you can see it. Syntax is a rule, a method, a strategy, or let's say if you are looking at human language, is a grammar or a way that you are going to create your sentences. That's what we call it, a syntax. So you have to follow a syntax. You have to use keyword, as you can see in here. You have to use operator, and you have to make sure that the symbols and punctuations, all of them are used in a right way, and that's what we call it, a syntax. Variables, I already said, something like creating an object. For example, in this function, this whole thing is a function. In this function, main is called a variable. Workday is called a variable. Main is a default variable, but workday is my customized variable inside this function. Variable is something that you can assign it based on your requirement. Like for example, in here I use workday. I can use even hour. I can use even maybe day or whatever. But still I have to redefine what are these stuff later at any other point inside the code. But still, these are something that you can pick the one that you like. But you cannot still customize the one in here. Hopefully that makes sense. So I'm going to go back to this example, like for example, hours, rate, pay. These are all what we call them variable. So next is, I already explained all of those, input, processing, and output. So this part is something that I truly want you to have a good sense of it. This one, I'm gonna just close the slides and focus only on software. Input, process, output. Input means just gather all the information that you need right in here. Like for example, my plan is just a simple code, which I'm gonna clean up. A simple code I'm gonna teach you. Suppose that you put together these few lines yourself. So input is I have to first get access. Input doesn't mean your physical input in here, means whatever information inside the code. Like for example, in here, I'm gonna start with addressing the right header file, IO stream. Then I'm gonna start defining the first line of my function. And then I have to open my bracket, whatever I need to be included in this code. In this example, I'm gonna use cout hello world. Cout hello world in here simply means just print out this only highlighted in blue line for me on the console. So these are my input. Now I need to process. Process means go ahead, hit the debugger on your software. Then you have nothing to do. You have to give time to your console to process it, and then automatically will generate the output on console. Let's debug this one together. I'm gonna hit this one. After some time, I can see a black screen will show up, and inside that black screen I'm expecting to see exactly the line hello world. So here we go. This is the black screen, and as you may see right in here, exactly what I asked, it was hello world, and the same exact thing is print out for me. So I simply ask my console, just print out this one for me. Now, can I edit this, print more? Yeah, I can go ahead. Either I can say hello world, maybe 1C E3, even if I add more, and if I close my debugger and my console and debug again, next time I have to see this additional one CP3 as well. So far you learned, look at here, I'm gonna highlight it. So far you learned in order to start a program, I'm gonna close up because that's the end of the lecture. Before I do that, I'm gonna bring up the same lecture slide and quickly review it with you. As you can see, I already covered all of the information that you can see in here. I taught you how to provide procedural programming. Remember this one. This is something good to remember. We do have two type of programming. The one that we are like practicing this semester is called procedural programming. Simply means we are going to start creating an object step by step. That's what we call it, procedural programming. In the advanced version of the same code called object oriented or 1PR3 right after this one, we are going to focus on object-oriented programming. So one CP3 is a procedural programming, one PR3 is object-oriented. Why do we call it object-oriented? Because in there I'm going to teach you how to create, for example, a single box in multiple step or in multiple file or as multiple object, or how to create multiple box and get them to exchange information together. That's why we say object oriented programming. So we are going to create some object, We are going to contain some data. We are going to link them. We are going to give them access to exchange information. And that's the advanced version of programming. Why do we add the slash n? A slash n in here is giving you option in case you have more line underneath this line 7. For example, I'm gonna do that. For example, if I copy this one and in here I say, just say maybe hello one CPTD. In here, just say hello world. If I do have a slash n, after I debug, this one will be printed in a single line. This one will be printed in the line after. If I do not have a slash n, both of them will be printed back to back in a single line. Let's practice it. So now if I debug, since I have a slash n, I'm going to have two separate lines. One showing hello world, and look at here, and one showing hello one CP3, right? Now, I'm going to remove the slash n and see what will happen. Both of them are expected to be printed in a single line. I'm going to debug again. Here we go. Look at here. Both lines with no, like, for example, listed down, no, like, for example, a slash n, are in a single line. Make sense? So that a slash n is giving us access to, no worries, is giving us access to clean up the printout or customize the printout. They may not have something like technical impact, but they do have some visual impact. Later, except a slash n, I'll teach you how to use even end l. End l is gonna do something very similar. So let me wrap up quickly. Over this lecture, which is the introduction to one CP3, we have learned what is software, what is hardware, which kind of software and hardware are available in order to go through a computer system. More specifically, what are the languages that we may be just required in order to just communicate with the computer. Remember, I said we have high level language, which is closer to human language, and we have low level language, which is more understandable for the computer. Low-level language are those which is a combination of zeros and ones, or we call them binary numbers. And high-level language, we can just have, like, I can even show you on a screen, binary to decimal, for example, or to hex. We do have different type of languages. We have binary, we have hex, binary, versus decimal versus hex. I'm going to show all of them to you to have a good understanding of what are the different type. Let me see if I can find a good picture. Yeah, maybe this one. It's not that bad. Even if not this, but not that bad. So look at here. Decimal is very similar, or actually human language. We say 0, 1 to 7. Binary means a combination of 0 and 1. Hex is still very similar to, for the first maybe 10, first 10 digits starting with 0, because 10 digit means by one off. We start with 0, then we will end up at 9, not 10. For the first 10 digits, including 0, hex equivalent is equal to decimal. But right after number 9, or the 10 digit, we are going to replace the numbers with character. Therefore, that's the difference between hex and decimal. So hex and decimal are equal only up to 10 digits, which is number 9. And anything after that, up to 15, is going to change. It's not digits, it's not number anymore. It's going to be alphabet. Now, binary is something that it is truly easy for. Let me give you another example. Binary is something that is base 2. Base 2 means, for example, I start from here, I get them to become to the power of 2 and calculate the equivalence in decimal, or maybe if I need to calculate in hexadecimal or whatever. So If I am converting to decimal, decimal by itself is base 10. Binary is base 2. And then hexadecimal or hex, either is correct. These are base 16. So, not sure if you have this in other courses or not, but if not, this is not really a detailed requirement for this course, but still I always love students to have some idea. For example, if I'm going to calculate something or if I'm going to convert something from binary to maybe equivalent in hex, so first I have to convert it in base 16, right? And just go from there in order to convert, for example, this one to the other one. But 1010 in this in binary is equal to 10 in decimal, but is equal to character A or alphabet or letter A in hexadecimal. Just keep it in this level because you don't need that in here. So I explained those. So we call the binary one low level language. The rest, like for example, high level language like hex and decimal are going to be more high level language because they are closer to human language than machine language. We have to go through a process. These are the summary of what I have discussed over the first session with you. We have to go through some procedural programming process, which I closed like the lecture with it today. I'm going to bring it up right in here, procedural programming, in order to convert the human language to machine language and make it understandable for the machine. I introduced some of the inputs, I introduced some of the outputs, such as monitors, such as, for example, inputs like keyboard or maybe keypad or whatever. These are going to be your inputs. I introduced the type of RAM and memory, like RAM is random access memory. The secondary, maybe storage, which is like, for example, your USB, DVD, and so on. And the most important part is going to be I introduce the platform that we are going to use, or more specifically the software Visual Studio, not Visual Studio Code, just Visual Studio. Any version after 2022 is gonna work. If you are using Windows and Mac, the type of file that you have to install is gonna be different. Please do not waste time. If you are using Mac, you have to go download the Mac version. It's different than the Windows version. And probably even your overview is gonna be totally different than what you are seeing on my screen. I am currently using Windows. I introduced the Windows to you. I introduced all of the tabs that I have here on top. I opened them one by one. I told you which one is doing what. Anytime that you are going to accidentally close any of your side tools right in here, such as Solution Explorer, I told you need to just quickly go to view and reactivate it right in there. I introduced some of the operators, syntax, keywords, punctuation, and stuff. And I am hoping everybody is comfortable with the detail that we shared today. Still, please feel free to rewatch this recorded introduction about programming, more specifically C++ programming using Visual Studio if you need to. For any of your extra questions, feel free to email me during the week. Feel free to just raise your hand, either use the microphone, use the chat, either the communication is also available on Avenue under each weekly module. I'm going to remind everyone about that. I'm gonna push this one. Like for example, under each lecture, please go and review what I have provided in here. Under each module, look at here how many options do you have. For example, you've got the PDF version of the lecture notes, like for chapter 1, chapter 2, and so on for the rest. You do have some resources in here. Under resources, usually I provide extra examples or the solution to the examples that I help you like programming during the class time. I include them in here. This is going to be repeated for every other module. You do have exact like equal information, but about that certain topic. Lab documents are provided right in here. You may not see all of them right now, but for example, first one is going to become available to you tomorrow. And also assignments, you've got a module in here. They are unavailable to you later. I'll make them available. And more specifically, under I think under communication. I have discussions in here. So this is another method of communicating with me. Just please be careful. How many method of communication I open for you? You are more than welcome to interact with me during the class time. I'll be more than happy to collect any of your question, share my answer from heart. You are more than welcome during the week out of class time to email me. You are more than welcome also to use either of this discussion forum. I do have two available discussion forum to everybody in a class to come share your questions right in here, and I'll try my best to answer your question as soon as I can and make the answer to that certain question available to everybody at the same time. To my understanding, this is the best method of communication. More specifically, if you do have some technical problem, which might be the same problem for other students, come here, hit the start new like forum, and just give it a subject the way that you provide email. But if you do it in here, everybody in the class can see it. I can see it, TA can see it. And even if somebody see it before I see it, they can immediately answer you, and everyone else can use the answer to that question. So this is somehow a teamwork, a great teamwork. This is programming, this is new, nobody is expected to know it in advance. We are going to learn and grow together. We are going to support each other. Put your questions here. Put your question, if it is personal, on the email or during the class time, ask me, and I'll try my best to just help you answering your question. So I'm gonna close my talking. Still, I'm available. I'm gonna stop recording, but still I am available for the next few minutes in order to collect any of your question and help you to leave the class with clarity.